Yes, class. So in the last class, we couldn't complete this entire derivation. So two equations, we reached till two equations, right? So when you are solving series LCR circuit, I told you that there's a condition when you get your entire impedance equal to the resistance of the circuit. That condition is known as resonance. And one more thing that you have to remember is that XL becomes equal to XC. That is one of the most important things. And one more thing that you have to remember, one was that resonance thing. Secondly, that current becomes maximum over here because your impedance is decreasing, so current becomes maximum. These are the points that you have to remember. So, and I had told you that during resonance condition, Z actually becomes root 2 R times. So using this, we had started our derivation. Only till here we could complete, right? So yes, I told you two equations will be, we have received two equations, omega 1 and omega 2. So let's just add 1 and 2. See, so if you add them, this becomes omega 1L minus 1 by omega 1C plus omega 2L minus 1 by omega 2C. And when you are adding all the right hand terms together, this becomes plus R minus R. So this actually cancels, right? So this becomes 0. Now what you can do is that omega 1L, omega 2L. From here we can take common. L can be taken as common. That becomes omega 1 plus omega 2 L. L can be taken common. From here, similarly, minus 1 by C can be taken common. So we are left with 1 by omega 1 minus 1 by plus. Minus I have taken common, no? 1 by omega 2. This entirely is equal to 0. Let's solve this because with the denominators, it won't be solved. So we have to take the LCM, omega 1 into omega 2. This will become omega 1 into omega 2. That becomes omega 2 plus omega 1. The rest of the details will be the same. Omega 2. This term is 0. So omega 1 plus L this term. So let's shift this entire term on this side because this is equal to 0 itself. So it actually becomes omega 1 plus omega 2L is equal to 1 by C omega 1 plus omega 2 divided by omega 1 into omega 2. See, omega 1 plus omega 2, both of them will be cancelled from this side. What is omega 1 into omega 2? This is equal to 1 by LC. Omega 1 into omega 2 is equal to 1 by LC. Okay? So this is one thing that we have derived from by adding these two equations. Suppose we subtract these two equations, both the equations, because with this omega 1 and omega 2 is equal to 1 by LC, we cannot come to a conclusion, right? This will be helpful. We'll substitute this value. We'll be needing it. You will see where you will be needing it. Now we'll subtract these two equations. We added them. Now we'll subtract these two equations. So now see, when you're subtracting, I'm not writing the entire thing. What will happen? Omega 2 minus omega 1 will be there when you will take common. Plus 1 by C, here also omega 2 minus omega 1 divided by omega 1 into omega 2. But on the right hand side, it is R minus and minus R this time. So that actually becomes 2R. In the previous case, it was plus R. This was plus, so they got cancelled. Right now, they both are in opposite signs. So one negative sign will make that it as positive, so that will become R plus R, which is 2R. Fine. Now see, what we can do in here is that omega 2 minus omega 1 just separated. Take common omega 1 minus omega 2. Then you will see terms clearly. Omega 1 minus omega 2 has been taken common. So from here, we are left with L plus 1 by C omega 1 into omega 2 is equal to 2. Now see, the value of omega 1 into omega 2 which you have obtained. Omega 1 into omega 2 is 1 by LC, right? Omega 1 into omega 2, this is 1 by LC. So now see, substitute this value, omega 2 minus omega 1. This is L plus 1 by C. Instead of omega 1 into omega 2, right? 1 by LC, right? This is equal to 2R. So C will become cancelled, L plus L. See, L plus L, that will be 2R, 2L, right? This will be 2L. So this is actually omega 2 minus omega 1 multiplied by 2L is equal to 2R. 2 will also be cancelled. So omega 2 minus omega 1 is what? This is R by L. This is also one very important equation that you have to remember. Now, what was quality factor if you remember? Yesterday we had started with quality factor. That is only what we are deriving. So what was the actual formula of quality factor? Formula of quality factor was omega R, that is the resonant frequency, divided by bandwidth. Remember omega 2 minus omega 1. I told you, no, that we take the resonant one and then subtract on the frequencies on either sides of it. So omega R means angular frequency at resonance is actually getting divided by the bandwidth, right? So omega 2 minus 1, omega 1 we have obtained. So one formula, final formula, this is the final equation that we have obtained. This can be now written as, this is R over here and L will go up. This is the equation which you have to remember for quality factor. How did we derive it? What are the number of steps? See, firstly, we used Z is equal to root 2R. We have solved this by putting the value of the entire formula of Z, and we have obtained two main equations, having omega 1 and omega 2. Fine. Now we have added them and we have subtracted them. When we have subtracted them, we reached to a point where it couldn't be solved further. This, because we don't know what is omega 1 into omega 2. So for that, we had already added them and found the value of omega 1 into omega 2. Fine. Now, once this is obtained, we have put in all the values and finally we are getting omega RL divided by R. Omega, not omega RL, it will be confusing. Just say omega L. That is resonance frequency into or angular velocity, you can say, but this is more commonly used for resonant angular frequency. Or all right, into L. L is inductance. L is inductance and R is the resistance. Fine. One more formula that is very common and very helpful for your examination point is, see, omega at resonance is 1 by under root LC. Let's square it. That becomes omega R into omega R is equal to 1 by LC. If we do one thing, if we interchange these, shifting 1 L here and bringing 1 omega R here, omega R L is equal to 1 by omega R C. Now see what is omega R into L. Can you see omega R into L is actually Q multiplied by R? Yes. So this actually becomes Q multiplied to R is equal to 1 by omega R C. So what is it? Resistance, bring resistance here. Omega R. What is omega R? Remember resonant frequency 1 by under root LC. See, if we are having 1 by C over here and we are having 1 by under root LC, so C can be rationalized and it will go up in the numerator. So it will become C by L. Sorry, L by C, not C by L. After rationalization, this will become L by C. So this is the formula, Q is equal to R. This is not very important for you to learn the derivation part. This formula is important, but the derivation part till here is absolutely important. This is how you have to write about the quality factor. So when the quality factor comes, what all things can come? The graph, the definition definitely. And when you're explaining the definition, you have to draw this graph. All right, it will not be mentioned in the exam to draw the graph, but you will be drawing it by yourself. All right. then the derivation for the formula of quality factor, and one more formula, that is Q is equal to 1 by R under root L pi C. Let's see. So you people have written till here already. Just start writing from here. Yes, class. So this question says, in series LCR circuit. And one more thing, class, please switch on your video. Please switch on your cameras. Focus mode is already on, so you'll not come in the recording as well. And secondly, you all will also not be able to see each other. So please switch on the cameras. Yes, in series LCR circuit, the resonant frequency is 800 hertz. Half power points are obtained at frequency 745 and 855 hertz. It means both the omega 1 and omega 2 are given. I cannot switch on. Okay, Chavez. Calculate the Q factor of the circuit and the bandwidth. See, this is the resonant frequency, that is omega R is given as 800 hertz. Omega 1 and omega 2, you have both of them. Omega 2 is 855 hertz and omega 1 is 745 hertz. Yes. So quality factor now we have to find out. Q is equal to omega R by omega 2 minus omega 1. So this becomes 800 divided by 855 minus 745. So that becomes 800 by 110. This becomes around 7.27 something. This will come. That's it, your answer. And second is bandwidth. Bandwidth is this only. 855 minus 745 ohms only. This is the bandwidth, not ohms, sorry, hertz. That is 110. Note it down. This was formula based question only. Some small circuits I want to discuss with you. Main LCR, series LCR circuit is over. One or two small circuits. Now this is easier in comparison to LCR because now you have gone through LCR. Yes, rest of the students, please instructions about the cameras I have given you. It's written also, I think, in the chat column. Except for Chavez. Only Tarif has followed the instructions. Okay, Faiza, Pia, Madiha. Now, C class. when we are talking about series LCR circuit, when we were talking about it, so it had all the three components, right? Inductor was also there, resistor was also present, capacitor was also present, right? Then we did initially, before starting with LCR circuit, what did we discuss? We discussed the individual circuits. Yes, you had the circuit having only resistor, you had the circuit having only capacitor, then you had the circuit having only inductor. So individual circuits we had seen, and then combination of all these three circuits we had seen, which was called as the series LCR circuit. Now, two combinations which can come in your exam, and they have actually repeated in the exam. That's why I want to discuss it separately. Otherwise, the concept is same as it is. Series LR circuit means capacitor won't be there in your circuit, inductor will be there, resistor will be there. So what will be the difference? You have to remember the phase differences first. I hope all of you have written. If anyone is writing, please text me. I'll stop. In series LR circuit, please be careful with the instructions when in the question you are given capacitor or not. If capacitor is not mentioned and only inductor and resistors are mentioned, then you cannot use the formula of LCR, or you cannot use the formula of individual circuits. You will be using this case only. Usually LR circuit and LC circuit, only these comes, and LC oscillation also, that has been deleted from your syllabus. So you just have to focus on two more circuits, that's enough. So resistor you have, inductor you have, right? Now, when we were talking about resistors, come to resistors first. When we were talking about resistors, we had noticed that current and voltage across the resistor both were same, right? Voltage and current both were same, in the same phase. Yes, there wasn't any difference. We had seen the graph also, both were in the same phase. Then in case of inductor, we had seen that current was lagging behind and voltage was leading by pi by 2. This was what we had seen. Yes. Now, if only these two circuits are present, now see how will your phasor look. And I have told you, class, please try to remember with the help of phasors only. This will be very helpful to you for your exams when you are revising. Right now, you're going through the lesson, no? But once you are done with the lessons, you will be having your revision test also. You will be having your revision classes also. After that, by just looking at this phasor diagram, you'll be able to recall all the things that we have done from this particular circuit. So try to remember through phasors. Now see, if let's say the resistance is this. Now let resistance is this is the voltage across the resistor. And then we have, now inductor is given, capacitor is not mentioned in your circuit. So this portion was for capacitor. We did it. So for inductor, when we are writing it, this is for inductor. Now see, when we had capacitor also in our circuit, we used to find the difference between them. Yes, V1, V2, we used to find the differences between these two, and whichever one was greater, we used to write that in the, like the parallelogram law we did, right? Now see, this is voltage across the inductor. Now you just have this in your circuit. This portion has been erased. This portion has been deleted. Capacitor is not there. So you will be focusing entirely on this. Now, how will the difference come in your circuit? When we were deriving for LCR circuit or any other circuit, what did we do? We used to subtract this VL minus VC or VC minus VL, depending upon whoever's magnitude was greater. Right now, instead of subtracting, you can write it as it is. When we see through the impedance triangle or E naught square, this will be simply VR square plus VL square. Yes, vector addition, Shaviz, right? Vector addition. You will be doing the entire vector addition. All right. It's just that instead of VL minus VC, which you have written in the derivation of LCR circuit, except for that part, you will just have entirely VL. Entirely VL square is given in your circuit. Okay, that's the difference. Otherwise, the derivation is as it is the same. The derivation is as it is same. Now, E naught square is given. So what is the value of voltage? This is current multiplied to the resistance plus I naught into XL. This is I naught into XL square. So same derivation is just that you have to remember it till here. Rest of the things are same. Now E naught square is equal to I naught square. This is R square plus XL square. So what is the value of I naught? I naught will be E naught divided by under root R square plus XL square. I is equal to V by R. Yes. Potential divided by resistance. So what is the impedance, net resistance of this circuit? This portion. So instead of getting XL minus XC whole square, this time what are we getting? We are getting simply XL square. Okay, we are getting simply XL square this time. So under root R square plus XL square, do not write that entire thing, XL minus XC or XC minus XL. That term has been eliminated. Otherwise, no, this is exact derivation what we have done in series LCR circuit. So what is the impedance for the LR circuit? Impedance will be, see this term, this is your denominator, right? So this will be under root R square plus XL square. That's it. Now see, cos phi will remain the same. Cos phi will still be R by Z. But coming to tan phi, cos phi, I have told you, cos phi will always remain as R by Z. Okay. Coming to tan phi, when we are talking about tan phi will be different. If you people remember and if you people have revised LCR circuit, I told you also to revise and come. In series LCR circuit, when we were writing tan phi, we used to write two conditions. XL minus XC divided by resistance or XC minus XL divided by resistance, right? Like this we used to write it. Now we do not have XC component. Capacitor is not present in your circuit. So what is left now? XL. So it's XL by R, or you can write the voltage of the inductor by the voltage of the resistor. This is the difference that will come. So it's actually easier. First, I will suggest you all to remember and learn series LCR circuit. That will be better because that will have all the three components. So this you will be able to tackle by yourself and you will find it easier also. Question also, let me show you one question. Let's discuss it. Then you people can write it down. See, either the circuit will be made 90 volt is given, 120 volt is given. So it means this is VR, voltage across resistor. That's VL, voltage across inductor, 120 volt. You have to find out impedance of circuit, phase angle and current. See, for finding out the impedance, firstly, we do not have the value of VRMS, right? IRMS to hai. We have IRMS with us, that is 3 amperes. What we do not have is that the value of VRMS. So how can you find VRMS? Net voltage. I have one voltage as 90 volt. I have one voltage as 120 volt. Can I simply add them? 120 plus 90 to get the resultant? No, I cannot. Because these are phasors. They have to go through phasor addition, that is vector addition. I cannot simply add 90 plus 20 to get VRMS because VRMS is not there in the circuit. I'll find impedance, I'll find phase angle. Using that, I'll find the current also. But VRMS, how will I get it? Right? So for VRMS, the best thing is that VR is given to you as 90 volt, VL is given to you as 120. So VRMS will be under root VR square plus VL square. That's it. Okay. So this will be 90 square plus 120 square, which is 150. 90 square plus 120 square under root, that will form a Pythagorean triplet. So that is 150 in English. Then we have to find out the impedance also. So yes, for the impedance, what you can do now here, because we do not have the values of resistances. Otherwise, this question was very easy. We could have directly used the formula which we have derived. Z is equal to under root R square plus XL square. This was the formula which we have derived. Yes. But we didn't have XL or R in our question. And we were asked to calculate impedance. So what you can do when you are writing this formula, no, it means this is valid for voltage also. This is valid for voltage. Ultimately, we had started with this only, right? E naught square is equal to VR square plus VL square. So we are actually using this equation. Why aren't we using the equation which we have derived? Because XL and R means resistances of inductor and resistance of the resistor. These are not mentioned to us. Okay, if you are given XL and R, then directly use them. Don't make your questions lengthy like this. But since we do not have the values, we'll be using this. We have VRMS, we have IRMS. How do we calculate resistance? Impedance or resistance is actually equal to VRMS divided by IRMS. So what is VRMS? VRMS is 150. Current is given, that is 3. So your impedance will be 50 ohms. This is how you have to find your angle. Now, second part is phase angle between them. You can use cos phi, you can use tan phi. Any of them you can use. Let's use tan phi because you have impedance also. You have yes, you do not have the value of resistance. Cos phi you cannot use. For cos phi we require resistance. We cannot use cos phi. We have only one solution for it, that is tan phi. Why are we using tan phi? Because VL divided by VR. This we can use. Right now, I have made you right now that you will be you people will copy, then you will find it better. What is VL? VL is 120. And what is VR is 9. So this becomes 4 by 3. So phi, that is the phase angle. Always use inverse trigonometric functions. So that becomes tan inverse 4 by 3. This is your answer. Now, one more circuit we'll be doing it, but we'll be doing it very fast because this is similar to it. So one conclusion, just listen carefully, then you people can note down entire it. When you are having individual circuits, remember the phase differences first. Why? Because if you go through the pattern for alternating current, you will find it easier. How to learn this lesson? Firstly, remember the individual circuits which are present. Fine. Individual circuits and which is leading, current is leading, voltage is leading by the phase angle. Phase angle is fixed 90 degree. Either it will lead by 90 degree or it will lag by 90 degree. But remember this first. Otherwise, if you remember that concept, which is leading, which is lagging, then you will be able to draw the phasors. Once you have drawn the phasors, then you will be able to write the derivation also. So individual circuits, then LCR circuit, and then do these two circuits because these are not very important. But you can get questions, so you should be able to tackle it. Note it down, then one more circuit we'll see, but first note this down. Any doubts if you people have, let me know. class. Now coming to RC circuit. So this time inductor is not present. Resistor is there. Now we'll do this. We won't devote so much of time in this. Both of them are in the same phase, current and voltage. Here current is leading the voltage by pi by 2. So this is VC and this is pi by 2. When we are talking about the phasor, VC will come in its own original quadrant, right? Now, what will be the difference? See, this is the final conclusion, E naught by under root R square plus XC, and how to derive this derivation is also the same thing. E naught square is equal to VR square plus VC square, fine? So, if you put in the value of this, that becomes I naught R square whole square plus I naught into XC whole square. So from here, E naught square will be equal to I naught square R square plus XC square. So from here, you can write I naught is equal to E naught divided by under root R square. So your, what is the impedance that you have obtained? Impedance's value is under root R square plus XC square. And what is the value of tan phi that has been obtained? VC by VR. Same thing exactly that. Now see, pay attention. You have 3 circuits. You are having 3 circuits. One is purely resistive, one is purely inductive, and one is purely capacitive. Fine. Then you have one combination of RL, one combination of RC, an entire combination of LCR. So these circuits you have to do. 5 of these and plus 1 LCR. Okay. So whenever you are revising, revise it in this manner, right? Note down this as well, series RC circuit. Okay, Fia, write it down. I'll show you LR circuit. See now, when we're talking about power, so formula of power is potential into current. So here we'll be using the entire complete formulas of current that we have. See, equation of current we have, equation of voltages we have. So we'll be substituting in the same. Power is equal to E naught, fine. So when we're talking about E will actually be E naught sine omega t. Multiply to current. What is current? Current is I naught sine omega t minus phi. So this you will be using in alternating current. Had this been DC, direct current, then you would have directly kept in the values of voltages, values of current. Okay. So E naught sine omega t into I naught sine omega t minus phi. This you will be using. Now see, in this equation, sine all the terms of angles, we can write it together. We can write all the values of angles together. So this becomes E naught I naught into sine omega t multiplied to actually sine omega t minus phi. So we have all the angular terms together, right? Now, see, if I multiply and divide, this is actually just to get an identity. This by 2 and this by 2. This won't make a difference. This is actually, this was it what we had. So now what I'm doing, I'm just multiplying this by 2 up and down. Now, why am I using this? Because there is an identity. 2 sine A. See, 2 sine A into sine B. Can you see? 2 sine A. A is omega t multiplied to sine B. B is what? Omega t minus phi. This is cos A minus B minus cos A plus B. Not sine 2B. No, not sine 2B. It's cos A minus B minus cos A plus B. I'll write it down. Cos A minus B minus cos A plus B. Okay, remember this identity for this lesson. This identity is not helpful for other lessons as such, but for this lesson specifically and for this derivation, you have to remember this identity. Now, after multiplying and dividing it by 2, we are at least getting a concised form of equation. So E naught into I naught divided by 2 is remaining here. What are we getting? Cos A minus B, omega t minus phi. Omega t will be cancelled, phi will be there, right? So that becomes cos phi. Why? Because see, when you're subtracting, this will become plus, this will become minus. So omega t minus omega t. This is how we subtract, right? Like terms will get cancelled, or the opposite signs will get cancelled. Cos phi minus cos A plus B. That will be cos. Now omega t plus omega t will become 2 omega t minus phi. This is what we are having. Now see, this bracket for you people is 0. This bracket is 0 because the value of cos theta and cos 2 theta, that is taken experimentally, and when the values are kept, that comes out to be 0. This is actually cos 2 theta. So this will become 0. 2 theta, cos 2 theta, and cos 4 theta. These are taken as 0. So this term will be 0. So what are you left with? See, second cosine terms average over a cycle is 0. We are talking about the alternating current. So when we are talking about one complete cycle, when you're taking an average, either you will find one more thing. Somewhere you will find this symbol is actually kept in the textbook. In a reference book, you will find this also. So that means average is taken. That means average is taken. So E naught into I naught cos phi by 2. Acha, one more thing, class. Root 2 multiplied by root 2 is what? Root 2 into root 2 is what?
2.
2, right? So it means I can replace and write this 2 as root 2 into root 2. Class, can you notice something? E naught by root 2. E naught by root 2. ERMS. Remember? We had ERMS value E naught by root 2. And similarly, when we are talking about this is I naught by root 2. I naught by root 2 is IRMS, which is I naught by root 2. So what is the final formula that you are obtaining? Power is equal to ERMS into IRMS into cos. Mainly you have to remember this. This will also be used. Derivation can also be asked in your exam. Power's derivation is asked. Okay. power derivation can be asked. And one more thing, class, if it's a pure resistive circuit, then we know there isn't any phase difference. No phase difference is present. So phi will be 0 degree, because remember I told you current and voltage both are in the same phase. So cos phi will be 0 degree. ERMS into IRMS, that's it. Because cos 0 degree is 1. Okay, this is the maximum value. So when is the power maximum? Power is maximum in purely resistive circuit. Fine. And when we are talking about inductive circuit or capacitive circuit, we know for both of these circuit, theta is 90 degree. So directly cos 90 will become 0. So you are getting the minimum value of power. You're getting the minimum value of power. Note it down from here. See, Fia, when we are talking about this identity, 2 sine A multiplied to sine B. What is A? What is B? What are A and B? They're actually the angles. So how can we write them? Cos A minus B. What is A minus B? When you are writing omega t minus this term, what will it become? Omega t minus omega t plus phi. Omega t will be cancelled. So you are just left with plus phi. That's why we are having phi. And when you're adding cos A plus B, so that becomes omega t plus omega t minus phi. So this becomes 2 omega t minus phi. Yes, class. Now just AC transformers, that is left. One topic. It's a very short topic that we'll complete within half an hour only the next Saturday. And next Saturday, we'll start with EM waves. All right. So one table I'll share on the group. I hope all of you are there on the group. I'll share one table with you. Please revise till AC and come. Class, this is a major portion of your first book. For your physics syllabus also, for your class board, 12th board exams. So EM waves is a very easy lesson. You all will be able to manage it. It's just a theory based lesson. You just have to learn all the numbers, frequency, wavelengths, sab yaad karna hoga. Okay. So just remember that EM waves will be done. It will be completed next week itself. Saturday, most probably by Saturday or the initial class of Sunday, it will be over. It's a very short lesson. Theory part you have to learn by yourself. But till AC, from the first lesson, please keep on revising it. You already have your revision tests. Revise according to that schedule. I have checked your first revision test. Only few students have scored fine. Many of you have not attempted the questions well. And please have a habit of writing the answer of correct MCQ first. Like if it's a B part, then write B part first. And then whatever answer is there. Do not escape writing the value of the answer, what exactly your answer is coming. Otherwise, you'll lose marks. And in the